All right, in this video, we're going to talk about how to convert more complex repeating decimals into fractions. Um, we're going to talk about when some of the digits behind the decimal repeat and some of them don't. So for example, we have 0.83 repeating and only the 3 is repeating, but the 8 isn't. So we can't use the nines method that we used for other repeating decimals. So what we're going to have to do is we're going to have to use a little bit of algebra to do this. So the first thing I'm going to do is I'm going to say there's some fraction, we'll call it x, that is equal to 0.83 repeating. I don't know what that fraction is, but we're going to use some algebra to find it. So now what I'm going to do is I'm going to use a little bit of math here to get rid of this digit that isn't repeating from behind the decimal, because I know what to do when all of the digits behind the decimal repeats. I can use my nines method. So I'm going to kind of eliminate that non-repeating digit by multiplying both sides of this by 10. So I'm going to take 10 times x, and if I take 10 times 0.83 repeating, I get 8.3 repeating. So that's going to be the critical step here, because now I have a decimal number where the only thing behind the decimal is a number that's repeating, and I know how to do that. I can use my nines method now. So I know that 10x is equal to 8 and 3/9. So I used my nines method to convert that decimal part to a fraction. And I'm going to simplify this to 8 1/3 and then write it as a mixed number. So 8 1/3 as a mixed number is 25 thirds. So now I've got my fraction. I just need to know what x is. So I know now that 10x is equal to 25 thirds. And now I just need to divide by 10 to get back to x, what I wanted to know in the first place. So if I divide by 10, x is 25 thirtieths, because 25 thirds divided by 10 is 25 thirtieths. And if I simplify that fraction, I get 5/6. So now I've got my fraction version. And if you check that by taking 5 divided by 6, you will get 0.83 repeating when only the 3 is repeating. So it's a little bit more work, but it's totally doable. We just have to use some algebra. Let's take a look at another example. So again, here the 2 is not repeating, but the 7, 5 digits do repeat. So I know there is some fraction that is equal to 0.275 with the 7, 5 repeating. I need to get rid of this digit that is not repeating. So to do that, I'm going to multiply both sides by 10. So I would have 10 times x is equal to 2.75 repeating. So again, I've accomplished my goal of only having the digits behind the decimal repeat, and the other one now is on the left side of the decimal, and I can write this as a mixed number using my nines method. This would be 2 and 75/99. So I'm going to simplify that fraction and then write it as a mixed number, and 75/99 is 25/33. So this is 2 and 25/33. And then I'm going to write this as a mixed number, or sorry, as an improper fraction. So 2 times 33 plus 25 is 91/33. So now again, I'm there, I'm almost there. I just need to know what x is, so I'm going to divide these by 10. So if I take 91/33 divided by 10, I get 91/330ths. And 91/330ths is in simplest form. So that is my fraction that is equivalent to 0.275 repeating. Again, if I want to take 91 divided by 330 to check that, I get 2.757575 and so on. So I know that is correct, that checks out. And usually these kind of repeating decimals give you pretty nasty looking fractions. So when you get a fraction like 91/330ths, that's usually to be expected. One more example. What if we have more than one digit that isn't repeating? Well, now we're just going to use a different power of 10. Now I need to get rid of 2 digits behind the decimal that are not repeating. So I know I have some fraction x that is equivalent to 0.124 repeating. Now to get rid of those digits that are not repeating, I can't multiply by 10. I need to multiply by 100. So a 100x would be 12.4 repeating. Notice now that 2 digits have been moved to the other side of the decimal by multiplying by 100. And then likewise, if you had 3 digits that don't repeat, you would multiply by 1,000, you would multiply by 10,000, 100,000, so on, depending on how many digits don't repeat. So again, this method will work for any type of repeating decimal. So again, now I'm going to write this using my nines method. This is 12 and 4/9. And then I'm going to write this as an improper fraction. 12 times 9 plus 4 is 112/9. So I have 100x is equal to 112/9. Now I need to divide both of these by 100 to find out what just x is. That would give me 112/900. And again, I would write that in simplest form. 112/900 is 28/225. Again, a pretty nasty looking fraction. But again, if I check that, 28 divided by 225 is 0.12444444. So I get the correct decimal value there. So that's how to find fractions from repeating decimals where not all of the digits repeat.